difficulties. There we are. Right. Oh, what a great thing turned out here. Microphone, phone, getting stage fright. All right. So we're here to talk, Sarah and myself, about what Watson is and why we say this new even computing, and we call it cognitive computing. So we'll first start talking about Watson, trying to do a brief introduction as to what it is all about and why what the fuss is. We'll talk about the capabilities, how it's being applied in different areas, in different industries. And finally, we'll look at real-world applications where it's being implemented. And we have a couple of examples here in Australia, so we're going to talk to. So at the center of what cognitive computing is are three key technologies that, even though they've existed for quite a while now, the way they've been put together allow us to bring and tackle a complete new class of problems that perhaps weren't as easy to solve before. So the first one is dealing with natural language processing. That's something that's been actively researched for maybe 30, 40 years. There's been very big improvements lately, especially with the amount of computing power that is available now for us. The second technology at the core of Watson is how we can actually generate hypotheses as what the proper response is to a given problem, and actually evaluate how good that response is to the particular problem that we're being presented with. So, and this perhaps departs a bit of what we used to deal with in computing, perhaps not if you're dealing with analytics and statistical models, but the idea is that instead of saying the answer is this, so if I'm asking you, I don't know, who was the Prime Minister of Australia in 1997, for instance, some of you might say, I have no idea who it was. Some might say, I think it was John Howard, perhaps it was Paul Keating, I can't recall. Others say it's John Howard. I'm certain he was the Prime Minister by that time. So what we're really doing is sort of measuring how good our response, how certain we are of the response to the question we're being given. And this is what Watson does all the time. Instead of always coming back with the answer, it evaluates lots of answers and comes up with the ones that Watson is most confident about. And the third component that makes it a bit different is that it can actually learn as it goes. It adapts and learns as it goes. And again, this resembles and mimics what we do. I mean, we start not knowing much, and as we get experience, Watson gets trained, we learn. We are better to give better responses, discard responses that we are told we're wrong. We don't give that response anymore. And Watson does the same, based on training and based on feedback from users saying, this response you gave was awful, this one's really good response. That incorporates and adapts the models and the line words. So all these three together, so all these three together are really bringing what we call a new class of solutions or systems, which we call cognitive computing. So they're not here to replace what we are used to, which is, we call it the programmatic paradigm in computing. It's an evolution of that allows us to tackle problems that are not as easily handled with programmatic. So we're talking about huge amount of data, we're talking about uncertainty in the responses, we're talking about structured content, unstructured content, sorry. So with Watson, we can tackle this series of problems. So let's talk a little bit about the history of how this all came to be. Perhaps some of you will remember, late 90s, there was this IBM research project called Deep Blue, which was meant to be a computer system that knew how to play chess. And it did it so well that it actually challenged the then chess master of the time, Garry Kasparov, and it beat him. So it was like, had a huge media exposure, and it actually, from there, evolved a lot of technologies that are nowadays in commercial applications that IBM has. So after this huge success, IBM Research started thinking, what's our next challenge? What can we do that pushes the boundaries again the same way that Deep Blue did? And they started thinking, maybe we should try and work with something that's question and answer related. So in the end, what they settled on is to actually build a computing system that was able to actually play on a US TV quiz show called Jeopardy, but play at the champion level. So that was the goal set. It started as a natural language processing problem, but then they realized that they needed more. The way that Jeopardy goes, it's been running for, 25, 30 years in the US, and there are three competitors that are asked questions, and they need to come up with the answer. But there's a twist. They're really not asked questions, they're given a statement, which is the response, and they need to provide the answer. So something like, this person was the Prime Minister of Australia in 1998. Then this correct answer would be, who is John Howard? So, and of course, if you're a participant and you give the wrong answer, you are penalized. So you need to be careful as to when you risk giving an answer or not. So, as I said before, it started all about natural language processing, and that's a big chunk of it because you needed to understand the question, then you needed to look at all the potential answers based on the knowledge base you had and match them up. But then they realized that it wasn't just enough natural language processing. Since you're penalized when you're giving the wrong answer, you actually, Watson needed to learn when to give an answer and when decide to pass the term. So that's where the generating and evaluating hypothesis came into place. So in the end, there were like 20 or so researchers working on this for at least 5 or 6 years, and around 2010 they were ready to say, yes, we are ready to do the challenge and do a real thing. So they filmed this challenge in 2011, I think, early 2011, and they actually beat the champions, the all-time champions in Jeopardy. So all of a sudden there was a huge media exposure. Everybody was talking about Watson, and IBM sort of said, okay, we have something really good in our hands. How can we apply it to the real world and help, solve real problems beside this sort of theoretical system that we built? And that's when they decided to actually actively commercialize the technology. And even though it's been 3 years ago, in Watson time, that's like 30 years ago, because things happen very fast in Watson. So from that moment that IBM decided to commercialize these products and started investing in making it like a real product, until now, there's been huge advances, both in terms of the computing power required to actually run Watson. It started with perhaps a room full of racks, and now it's running in, I think it's in 4 unit spaces, so it's been really decreased. The kind of problems it can tackle, it started with all the knowledge base that you needed in order to be good at Jeopardy, so it was Wikipedia, some movie databases, that sort of thing. And now it's really applied to particular industries, and you can train it based on particular corpus depending on the industry you're using it for. Early this year, there was a new IBM division announced to commercialize Watson, which we're part of it. We are part of the implementation arm of it, so we really have to make this work. And yes, and so here we are, and we started to see actual results with this. So let's talk a little bit about what happens in this question and answer. We call it pipeline internally. What happens from the moment that you put put a question until Watson is able to come up with an answer. The very first part, I'm not sure you can read down, that says inquiry analysis. That's pretty much understanding what the question is all about. Is it we call it what's the focus? It's a who question, it's a where, it's a what question, what sort of thing I'm trying to ask here. Then you might have to decompose the question into multiple parts. Sometimes you have compound questions, parts might be completely independent, or one might be subordinate of the other that gives context to the question, to the real question. And once the question is understood, for each of those components of the question, Watson starts generating a hypothesis. At this point, it's casting a wide net, trying to come up with all the possibly relevant answers that might be for that particular question. And this is a bit of a brute force approach. It might be just doing simple search based on keywords, for instance. So you might come up with perhaps hundreds of thousands of candidate answers for the question. Now, for each one of those candidate answers, here comes the part where we start evaluating how good that answer is for, that candidate answer is for the question. This is done across multiple dimensions. There are multiple algorithms that look for this match on a particular aspect. So for instance, you might have things such as how well does it match in terms of keywords. It could be things such as temporal reasoning or geospatial reasoning. So for instance, do we have a date in the answer? Is it a when question? That sort of thing is called temporal reasoning. And there are perhaps hundreds of algorithms. Each one of those will produce a score, saying this particular candidate is 100% excellent response to this particular question based on the criteria I look for. So after this point, we might have 10 of hundreds of numbers, candidate scores for that given question and that given candidate answer. This is the part where the statistical modeling comes in place. So when you train Watson, you're actually building a statistical modeling that represents how well a particular sample answer does in a particular sample question. And once you run the candidate answer against that model, you come up with a single number that says this particular candidate answer is really between 0 and 100% good match for that answer. Finally, what Watson does after it's evaluated is 10,000 or perhaps 1,000 candidates, it comes up with a list of the top 5 or the top 1's answer, and that's the one that's finally produced. So there's huge numbers of mathematical computations going on while we're talking here in order to provide might be a simple paragraph as a response. So just to give you an example of one of the typical questions we get while we're talking about Watson is how it's different from Google, right? So one of the things that Google is really good at is keyword search, and it has a massive amount of corpus. The content it's got is incredibly huge, but it's mostly keyword search, and then you're left to sort of sort through all the candidate answers to find the one you're best looking for. So I'm not sure you can read here, but this is an actual example from the question, which says, in May 1898, Portugal celebrated the 400th anniversary of this explorer's arrival in India. And here we have a candidate answer which says, in May, Gary arrived in India after he celebrated his anniversary in Portugal. Of course, if you do of course we are dramatizing the example here, but if you do keyword search, this is a perfect match for the answer, right? And we might very well conclude that the explorer was Gary. So we say the answer would have been, who is Gary? And let's look at what happens if we apply different types of reasoning against the same question and perhaps a different passage. In this case, it's on the 27th of May, 1498, Vasco da Gama landed in Capad Beach. So if you look at, one of the things that Watson does deep parsing of the question, so it actually understands the structure. So the main verb, the main action is celebrated. What was celebrated, we still don't know, but we know that Portugal is something that it was celebrated in Portugal, and we have a temporal date here. We have May 1898, and we have the 400th anniversary, sorry. With temporal reasoning, you can see that this is a very good match against the same thing. If you have a date which is 27th May 1498, it's a really good match against those two elements. Similarly, if you look at synonyms of paraphrasing, arrival in and landed in are really good matches, so that's a good score there as well. And if you also have some sort of geospatial reasoning, you know that Kapat Beach is in India, you can actually match India to Kapat Beach as well. And you may very well conclude that the explorer really is Vasco da Gama. This is, of course, is just an example, but that's the sort of variety of reasons that Watson applies in order to be able to come up with a response. Yeah. So now we're going, before we switch to the capabilities, if you have any questions, perhaps this is a good moment to talk about it. Yes?
Does it work in other languages than English?
Not yet, but it's been, as we speak, it's being trained in Spanish and Portuguese and Japanese. But there's no product yet, but it should be ready sometime next year, I think.
How much more effective is it in comparison to Siri?
Siri is a different thing, it's a different beast. What Siri does very well is it is very well connected to the applications that run locally on your iPhone. So if you say, call Bob, it knows that it needs to talk to the phone application in your app. If whatever you say doesn't match any of the application live phrases, you're not setting up an appointment, or you're not calling, or you're not saying text that or whatever, it actually just goes and does a search on the internet using Wolfram Alpha, the search engine. So it's really just a search engine. Whatever it comes back for, it's just a potential number of matches, and you need to work it out. Watson, in comparison, you can think it's a purpose-built search and reasoning engine. You normally don't apply it to broad domain, even though the example for Jeopardy was Wikipedia, so you can say yes, it's very broad. But you apply it to particular domains, something like, I don't know, insurance products or things that happen in a university, just to come up with a few examples. And in there, it can actually not only find the potential matches, it will actually present back to you the best match. It will give you the confidence, saying, I'm 88% that this is the answer, and it can show you the evidence why it thinks that that's the best answer.
When you train up the new data sets, are they available for any of the new users that you're commercializing for?
Yes, we'll talk about the content story in a bit. Yes.
Does it have a kind of a distinction between real-world observations and people's opinions? So, for example, a record from a temperature sensor is an objective record of the world rather than a subjective record?
Okay. Really, Watson doesn't know about objectivity or subjectivity. Whatever is in the content is truth for Watson. So if you put in the content that the sun rises in the west, that's what's Watson going to come back as an answer when it says where does the sun rise.
Does Watson have a live connection to the internet, or is it pre-downloaded?
It's normally pre-downloaded. There have been examples in which we connect it live, but normally it works on what we call a curated content.
Would Watson ever Google something?
Not by default, but we could. Yes, there are APIs. So Watson is always offered as a service in the cloud. And one of the key components are, because one of the things we're trying to do is build an ecosystem of partners. It's, which you'll talk about, so I'm not still in spot, but there are APIs that allow you to build your own Watson-powered applications. Yes.
In my experience, just following up on what the gentleman asked, the gathered experience of data versus the experience fed in by the line of business owner is always the point of contention. See, so I think in business, I would think, I have come across situations where that has to be the. So does Watson address that issue?
Yes, so maybe this relates to his earlier question about weight, assigning weights to different sources. And so the lessons learned have really been to recommend against that, so that we don't actually impose the subjective view onto Watson, but to leave basically Watson almost basically without that weighting, because in most cases in Watson, it is the human who will analyze the evidence brought forward and then select, based on the evidence and the confidences, may select the next action to take. So Watson will not make that final decision in most of the scenarios. So that's why it is recommended not to put that bias in, but rather, because it will be, without a doubt, it will be in the analyst's head already. So you want to leave the sources basically at the same recommended sort of level of credibility.
Okay. Right. Wolfram Alpha, it's actually manually trained on a particular, I would say, perhaps narrow set of content. It knows a lot of mathematical functions and formulas and things like that. It knows about weather and geographical places. But if you take it out of its comfort zone, a Wolfram Alpha doesn't know how to answer. Watson, on the contrary, you can train it on as broad as a corpus as you want, and if the answer is there, Watson will come back with it, even though it might have not even been heard that question before. Wolfram needs to be trained before it can answer about a particular topic.
So maybe just a comment on that domain adaptation. So typically, when Watson is applied to a new domain, so there is definitely additional effort and training. Typically, it would be trained on, let's say, the ontology, the concepts that are important in that particular domain, and then trained on question-answer pairs. Typically, the job of a Watson trainer will be to feed representative questions and answers for the domain, and to basically say, yeah, this is a good answer. Now, after the training cycle, obviously, there'll be testing on questions that Watson has not seen before, and that training, there'll be testing on questions that Watson has not seen before. And typically, because the ability to infer, to understand the variations of language, Watson will be answering questions that it has not seen before. So typically, so you do not have to actually show it every single example. Otherwise, you'd be back to a rule-based system where you say, this is the input and this is the output, right? So that is not the case here. And typically, when we do client implementations, clients will have their own test set, their blind set. We don't know. They'll keep some of their questions and answers, and they'll be actually testing after IBM, and together we train the system. They'll have their blind set to test the, if you will, the ability to correctly answer questions that Watson has not seen previously.
Do you want to train it on good answers? Or do you train it on bad answers as well?
Yeah,
Normally, you train it on good answers,
Yes.
right?
that's right. Yes, so
Because
there.
you want the model to be as close as.
Right, what do you think? Tell
No, no.
go with good answer.
Yes.
Yeah, it's sort of like supervised learning, where you give the input and the output, and you say this is a match. Yeah.
So this is handle unstructured data like images and sound at the moment?
Not yet, no. It only works on text at this moment. That is being part of the research that's being taken in Watson now, but it won't be commercially available for at least a couple of weeks.
So in some cases, there have been implementations where, for example, video transcripts, which describe what's happening in the scene, are then, that is the source of the answer. Because then again, it's text. So that would be a way to get around it if you have captions or transcripts.
To what extent is IBM publishing the algorithms behind Watson, or even moving into publishing the code? And how do you see that evolving over time? Remove it from the black box context.
There is a huge body of research papers published in many scientific peer-reviewed journals that explain all the variety of algorithms applied. And I mean, it's part of the training. Harry, there are like perhaps 20 hours of reading just the papers. It's not easy reading, let me tell you. But that's very publicly available. But as for the code, I don't see it as being published in open source or anything like that for the moment, because IBM does have a commercial advantage after putting this many years of research.
And perhaps what is publicized is the APIs. So there's the open invitation for app developers and companies to develop cognitive applications against the APIs. So that's a kind of a way to also create new applications against those which we haven't even thought about, right? Yeah.
So there's the next question.
That's how it started. But Sarah will talk about different applications that perhaps were thought of at the beginning. Very interesting.
For the questions, do you have multiple responding to one question in your training set?
No, normally, I mean, you always pick the best answer because that's how the mathematical model is created. It's essentially a classification problem. You say, for this particular sample in my training set, this is the answer. And that's how you build the statistical model.
One answer.
Yes.
But when the answers come back, then as Deborah was explaining, there will be multiple answers, probabilistic answers with weights associated. And then depending on the application, whether you want to reveal just the one best answer, or whether you want to reveal the best answers and leave it to the analysts to choose and to further review the evidence. So different modes exist. Yeah.
For one person could have a few more or several correlated answers, or be one of them maybe more. When you cannot say it's wrong.
When you're training it, you choose one answer because that's how you build the model. But once the model is built and you're actually running Watson, it will actually, as Sarah said, you can, in theory, you could present the top 100 answers that best match the question. Top 100, top 5, whatever you feel like it's best suited for your particular app.
Is Watson a neural network? Is that what's behind the term?
The mathematical models do have neural networks. And
Part of the neural network is it the hypothesis?
the hypothesis evaluation.
Right evaluation.
Yes, so with the hypothesis generation, you then produce heaps of scores that evaluate candidate answers. Then you run all of those scores are input to the neural network and other type of models as well.
The generation of hypotheses, what technology is behind that?
Oh, there are heaps of technology there. They're all built in a framework which is called UIMA, which is Unified Information Management Architecture. And in there you can plug in multiple, we call them annotators, which look at particular aspects. So you have annotators for keyword search, you have annotators for all of these things we mentioned, geographical, geospatial reasoning, that sort of thing. That's the underlying architecture.
What that means
It's all over the place. There are heaps of annotators that look at, you have shallow parsers, you have deep parsers, you have a whole heap of other different ways of analyzing the natural language. And you use it both for understanding the question and for searching and evaluating the content. You use that for both places.
And in addition, the domain-specific ontologies, which would be converted, so that the inferencing for Kappa Beach being in India, so that is it's simply a geographical ontology. An ontology. Ontology, yes, which may have concepts and related concepts, and they are tied together by a relationship.
also when you're training Watson, sometimes you need to teach it about the particular lexicon that's used in that domain. And it was interesting, perhaps we can talk about it, but in one of the first implementations of Watson's done worldwide was here in Australia for ANZ. We'll talk about it later. But the thing is, Watson needed to be taught the Australian dialect, the variations in English that Watson didn't understand because we have been trained to use English.
Just wondering if we could just move on, not to lose too much time, and certainly take questions at the end of the session.
So I might just go through, just to clarify some confusion, I wanted to take a minute just to, for those of you who have possibly been watching the media and are as confused as we are, because Watson branded products and offerings are out there. So I just want to give you a view of sort of the key 5 and where they sit sort of in the Watson portfolio. So the first I'll talk about is Watson Engagement Advisor. So this is the kit that allows you to build applications which are question answer. So typically this would be scenarios where the user is looking for information and they want a single answer back. Typically it's implemented, let's say a customer service scenario, for example, would be one. We're building one at Deakin University to advise students. So student asks a question and a single answer comes back. So, but behind the scenes, Watson Engagement Advisor implements exactly that full pipeline of it's being trained, it learns from user feedback, and it understands natural language. So it's got all of the 3 key cognitive components, but it's sort of packaged in a way to say, here's a way for you to build question-answer applications. So that's the first one that you may have heard in the media. And this does sit in the, if you will, Watson sort of has applications that are more in the cognitive space, so this is definitely a cognitive application. The second one that you may have heard about is now Discovery Advisor. Again, in the cognitive space and implements the pipeline, but in this mode, this is more of an analyst tool. So in this mode, the analyst will be, doesn't necessarily have a question in mind. They may start with a statement or hypothesis that relates to their area of study. This could be life sciences, it could be an intelligence analyst. And Watson presents a whole number of evidence that are the highest, that have the highest confidence, as responses. And this is the mode where the analyst is more interested actually in the passages that are returned than the actual answers, because it's in the evidence that they may find concepts and statements that they haven't thought about. So that's the discovery aspect. So this one is perhaps less of a sort of a end user. It is for a specific audience, more of an analyst user persona, if you will. I think you skipped 2. No. Let's go next. Okay, that's fine. Okay, and now mentioned before that there are some of these applications that IBM has built, Engagement Advisor, Discovery Advisor, but really the model that IBM is wanting to get into is that it shouldn't be, we will never think of the best applications, best cognitive applications. So so I think there were some questions about how one would use the API. So there's actually a cloud-hosted environment called the Watson ecosystem, where different types of partners can actually partner up with IBM. And the first one is the obvious one, app partners. So anybody can build an application and code against the published API. And one might also use it to upload their own content sources, train Watson, go through the entire cycle that we would go through in a client implementation. There are also content partners. So content partners may be those who are actually building ontologies and domains that then become, let's say, an industry-specific domain. All papers published for medical research, for example, for a particular domain. So content partners may be actually making their content available through the APIs so that others may build applications against them. So ISVs may be in either of these categories. So there are also some general knowledge content already that's being used in other implementations that's made available through this channel. And then the third one's sort of interesting is really talent partners. I get to partner with companies who have the talent to build cognitive applications. So if there are clients out there who say, I have a great use case, I don't have anybody to build it, but I'd like to partner with this particular company that has the talent. So all three of these are sort of ways to engage with Watson. That's not necessarily a client relationship. So these are different types of partnerships. And if any of you are interested in any of this, so we can take it offline afterwards for questions. So that's sort of like if we will build the truly cognitive space of Watson portfolio. And now we'll show a couple of other applications. So Watson, if you can go to Watson Explorer first. These are out of order, so keep going down back. There we go. Okay. So this is sort of your more classical, perhaps, more classical information access system. This is often called the 360-degree problem. You need to know in your enterprise everything possible about a particular entity. It could be a customer, or it could be a truck, or it could be a vessel, or depending on the domain. So Watson Explorer is basically a whole set of connectors and transformation capabilities, unstructured data backends, structured databases, and basically have the ability to build a kind of a portal-like application, which can then very quickly, almost by building almost like widget-like components, which then go against different backends, and then the logic to basically pass an entity return from one to a next widget as input. So this is I think that some of the scenarios here is actually in the customer service. So for example, a customer calls up and they say, I have a problem. Well, this is a quick way to see who's called that person before, what problems have they had in the past, what's their payment history, what's in the CRM. So you could actually build that up fairly quickly, and the speed here is the key. And the key also is that all of the data resides in the backend stores. This is a mode where you don't ingest them in. So Watson Explorer is really sort of a way to search and then bring that information back. Nothing is ingested. Okay, and then we come to the Watson Analytics, which is perhaps the most, Phil was thinking that this would be perhaps the most relevant for data scientists. And so we thought we'll actually, instead of speaking to it, we'll just show you a very, so if you click on the chip, we'll show you a video which basically summarizes in a very elegant way the capabilities of Watson Analytics. So I'm going to let you guys, everybody watch that, and then we'll come back. Okay. Oh, this is not going to be, yeah, we'll have to do it through the, let's see. Yeah. Yes, okay, let's do that. So we'll come back to this. We'll come back to this, and let's look at, what we can do meanwhile is look at implementations, examples of implementations. Yes, of course. Yes.
Have there been any kind of security applications for it?
Yeah, and those are often those would be classified, so we wouldn't be able to give you names yet. probably the most successful implementation of Watson, which resulted of about 4 years of partnership with MD Sloan Kettering in the United States. You may have seen it in the media, but we just wanted to bring it here because it is this sort of tells the story of Watson being in support of an oncologist's decision making. So there are about 80 hours worth of reading being published every week in the oncology research. So a single doctor apparently spends 30 minutes a week, so you can see already where the issue of keeping up is not possible. So the system really is built to rapidly ingest all of that new information continuously. So that's one of the modes where it's updated continuously, and there were for 4 years oncologists who were training the system in basically teaching Watson the reasoning of what is a patient record and then what is a suitable treatment. So basically showing the patient record is the input, the question, and the answer is a successful treatment. So it's sort of the question-answer mode, but in a much more complex domain. And essentially this is now managed to capture the subject matter expertise in such a way that this is now an implementation that a hospital in Thailand is implementing and successfully for oncologists there. So it's probably a best story of a long-term commitment from a partner to have their SMEs teach and continuously teach Watson. So it really is a partnership. It's not sort of a one-time done, but it is an ongoing partnership. And then this is what Deborah and I are both actually working at Deakin University right now. And you might remember when you were the new student and you arrived on campus, whatever campus you were on, you know, how puzzled and where do I go and what do I do and where are my classes and what's my timetable and where's free food. So we are in the first phase of this implementation, which is to go live in February, to answer new students' questions as they start the first trimester in February. And the first phase of this, so you'll see some of the sort of prototype questions. These are actually valid things from Deakin itself, but in varying degrees of complexity. So we start with simple Q&A. We go into questions that require what's called disambiguation. So the student doesn't provide enough context for Watson to answer. So you need to have clarifying questions, to have a fully specified question, and then going all the way to what we call process flows, which may be multi-step interactions with Watson in the area of career advice. So really, and that third step is still very much a collaboration with research. So that's how we spend our day jobs right now with Deborah. And yeah, I think so. So a little. And then I'm going to let Deborah talk about ANZ Bank because she's involved in that project as well.
Yes, so actually ANZ Bank has gone live with this last week. Still in a beta mode. It's not available to the general public, but it's available on the Wealth Centre in Sydney on Pitt Street Mall. Actually, there are iPads there in which customers can go in and ask questions about insurance. That's the first release that's made available. And Watson will answer about what type of life insurance do you offer, what am I covered for, that sort of thing. It's all there. And this is the example I was thinking for the training that had to be done for local adaptation. As I said before, this is perhaps the first implementation outside of the US that was done with Watson. And Watson had no concept what an excess was. They just didn't understand. It has a completely different term in the US. So that was an interesting journey. It's still going on. It's early stages, but it's live. This is a fun one.
Okay. Is anybody hungry? So you may have heard about Chef Watson. So Chef Watson started off more of as a fun thing, but actually evolved into a true implementation. So in partnership with Bon Appetit magazine, so understanding chemical compositions of different ingredients in recipes, and then building a map of what tastes good based on the chemical composition. So you can ask Chef Watson, for new recipes. And one of the classic Chef Watson suggestions is Vietnamese apple kebab. So now if you think about it, apples don't grow in the tropics, but Watson doesn't know that. So the chemical composition is apple will be similar to other ingredients that usually are used in Vietnamese kebabs, although I don't know what a Vietnamese kebab would be. But in some ways, it actually combines things sort of without any subjectivity. So any cook may have, any chef may not have thought of that combination. And actually, a lot of chefs have been involved in this fun project and have said, I have to say that first I was very skeptical, but then when I realized that I didn't even think about those combinations because I myself have biases about what goes together. So that's a sort of another example of discovering of new combinations which one wouldn't think about because of how we have been trained. Retrained. So I think those were like our four examples that we wanted to show you, and if we could, we might do. Phil, do you want to play the Watson Analytics video after the break, or
Do that now.
we can do that now? Okay, very good. Yeah, let's do that. So we leave you with the Watson Analytics story. So maybe we go back to. Okay. And maybe meanwhile we can do a few question answers while they're setting it up. Sure.
Which one of the ones was it? Discovery, was it analytics?
Engagement advisor. So it is the question answer mode. So, yes, that's right.
That's the thing. It looks very simple because in the end somebody types something and magically the answer comes back. But all the technology that we talked about is put in play in order to come up with the answer.
So what was the training data?
The training.
Data questions.
Yes, exactly. So the first, the good one, they actually collected data using a survey of the customer base, saying what you want to know about insurance. And they collected something like 15,000 questions, covering a whole breadth of things that you might think about insurance. And those were used to create, the training set, the test set, and the blind sets.
And then, of course, SMEs from the bank needed to tell Watson what were the right answers. So that's where the whole partnership, we don't have that expertise, but that's where the NZ Bank will supply hours and hours and hours of SMEs doing the training. Yeah.
I ran back from the airport the other day and saw a sign, skis made. What's the story behind that?
Excuse me. I didn't hear you.
It's a big billboard on the way back from the airport. It says, Ian Watson, skis made of China. So, I'm puzzling about the phrase and just wanted to see if there's a story behind that.
I think it's a marketing logo. We'll find out how much thought. Probably a lot of thought went into that. I'll get back to you.
We'd have to ask the marketing ones, guys.
I did read something on the billboard, the same billboard, that they were analysing the weather and predicting the likelihood of how much people would want to purchase skis. So they were doing all these analytics and trying to work out how many skis would be purchased on a weekly basis.
Yeah. So that would very likely then be Watson Analytics, which can actually have predictive modeling in it, whereas these cognitive capabilities that we showed, there's no prediction. It is what is in the corpus, that is the truth, right? So that I can say that it wouldn't be then a cognitive Watson, but rather an analytical Watson.
So if you had, say, some corpus, say the bank, and it had all these rules and regulations and it had a community about, then the management comes out with a new policy or the government passes a new law. So it's a very thin set of new evidence, but it has to be a constraint over the past knowledge. What is now legal? How does it cope with this big change in what's allowed to be true?
Yeah, so that's a very, very relevant thing. This ingested information into Watson it's valid the moment it's ingested, but it may well change at a frequency. So typically things that change to the minute, like sort of feeds, they wouldn't actually be in Watson, ingested in Watson. The context around it might be, but that actual real-time data wouldn't be ingested. However, there may be cases where policies, for example, change, and that's a perfect example. Maybe there's a yearly update, or maybe there's a sudden update, that there's a new legislation, and then that needs to be ingested. So there is definitely, Watson alone, it can never be outside of a sort of an overall enterprise architecture. So obviously, curating, identifying what is the data source for a particular piece of information, so that's key information. And that whole landscape actually, it's still being developed. So we work, for example, with Beacon. We're working out a solution of how we map the answers to their backend, either web content management systems or enterprise systems, and then basically build that pipeline or kind of a notification system. Something changes. What do you do? Is it consumed by Watson? Yes, it is. Should it be automatically updated? Probably not. Maybe it should be manually updated by the fact that somebody looks at it and says, yes, this is a significant change and I do need to be ingested into Watson. So there is a whole linkage of Watson into an enterprise, enterprises and information stores that's sort of above and beyond what we've discussed here. We're sort of talking about it from the front customer view, user view, but obviously there's a lot more to it to map it.
Just last question. Did anyone unleash Watson on
So there is Discovery Advisor on there is a ongoing assessment with the partner in the law industry, if you can call it. You said patents.
I was saying that it's not only law, but also search for similar patents and things like that.
Do you expect Google to start competing with Watson in the future?
Well, we see a few signs of that actually already. So you said whether Google is competing. Already we see it because we were doing one of these assessments for one of the unknown clients that we didn't talk about. So, and the client wanted to know, so how good is it? I mean, and the obvious question that comes to their mind, as they don't really understand, I mean, algorithms are for the techie audience, but the business user. So why is this better than Google? And so just as a mind exercise, we'll say, well, let's run all of the questions and let's see how good we are. And before I started, so actually the two of us were working on it, before we started it, we said, well, we already know that Google sucks at saying, I'm looking for a location. When or where is Alex Vela? Okay, our famous gangster, right? Where is Alex Vela? And we say, okay, where is Alex Vela? So of course, Google statistical Alex Vela will come up. But does it really know that we're looking for locations? And darn it did. So there was already this notion that it's about the focus of the question, that so they are combined, definitely combining statistical with looking at the focus and then trying to find. So I think, yeah, they are heading that way, but of course, we don't have this, knowledge of specifics of what algorithms they would be building.
But then to me, that question is almost a little bit farcical because, if you're talking about the previous law example,
yes.
How on earth can one expect law Google to give a legal interpretation of a particular problem, which is, I think, where that gentleman was going with, free legal advice, etc., to make democracy a little bit more accessible.
So of course, that was a very simplistic example I gave, but that's exactly right, that within a domain, you do need to build a knowledge of that domain and what concepts and how they relate to one another. And that's sort of part of the Watson domain annotation. Google is doing the same for domain-specific search engines. I'm not privy to that information, but I imagine that would be there as well, coming at least.
Just add category. Is there a Watson corpus of sort of core knowledge and individual use cases trained in specific courses? Is there anything Watson knows without being trained?
There are actually very
There is no one Watson. There are multiple instances of Watson trained for different purposes. Perhaps the most widely examined similar to that is the one that was used in Jeopardy. It actually had ingested all of Wikipedia and a whole host of similar type of content. So yes, it kind of knew a little bit about everything, but it didn't go, it couldn't tell you anything about insurance that ANZ offers, for instance. So the reality is that apart from content that might be available on the content store, because somebody says this content might be applicable for many applications, normally you build the content for your own use case. That's how it works.
I think we should run this short video now. I know there's more questions. We'll try to get them as well. Let's just try and progress to this point, and maybe just look first to it. This won't take too long, just about 10 minutes. Just to give you an idea of what's the melody is all about. Hopefully we'll have sound this time around.
Let's get started.
So what I wanted to talk today with you about and show everyone was Watson Analytics. It's IBM's innovation that reinvents the analytics experience on the cloud.
Excellent. Let's get started.
All right, so we've got a bit of a previous setup, make sure we transition quickly. We're going to do a bit of artistic license here. I'll play the role of an insurance marketer. You'll be my C-level executive, so I'll be asking for budget and stuff and showing why I should get it.
I brought my checkbook.
That's right. So we've already logged in here, and this is the home screen to Watson Analytics. And you can see it's walk-up intuitive. We can see immediately what we can do. We can start from a story as a marketer or as a finance person or in operations. I can even sort of cancel these out if I want to bear it down to just the things I'm interested in as a marketer. That would be here, improving campaign effectiveness, refining leads, and so on. Or I can dive in, I can explore my data, predict and explain. So let's skip ahead, and I've got data that IT has provided for me. It's curated, it's centrally controlled, I know what's up to date. They've even integrated some Esri data in there for me, so I've got the geospatial stuff, the superfood, as Jeff calls it. So let's go over and have a look at that here. Now what's really cool, and what hits you straight away is, I know straight away how good that data is. And it's, 68 is a good score. It's certainly better than me guessing. So we're already looking pretty good. And what Watson Analytics has done is it's started doing some data preparation. It's actually found some fields that it should get rid of. It's got missing data. You can see here 2 of them have constant values, probably names. They're not really useful. And then down here, it's even started finding things that are interesting. Maybe I should have a look at these things. So I could actually then go forward and accept these changes and improve this data score. We won't do it today for the sake of expediency.
Marcus, 80% of the time on any analytics project is really burned up in that element of preparing the data for analysis and for insight. And with lousy data, you get lousy insights. So this is amazingly valuable right up front in that it gives you insight into the quality of that data that you're going to use for your analytics project.
You're absolutely right, and that's across the board. I mean, just using Excel, people do deduplication, sorting, fixing phone numbers, everything, all the way up to a data scientist. And you're right, 80% of the time, that's a huge chunk of time. And there it is, it's already done. Great. So I usually would have skipped it, but it's being done for me, and now I can see what's happening. So let's go to the next step here. And we've got our data. I am going to go into a customer value analysis. Because as a marketer in this insurance company, I've got a campaign going, hit the West Coast, trying to get all these people to renew their insurance policies. And I've got some results. So this is what IT has actually provided me. So Watson Analytics has provided some suggestions. Here's some suggested analysis. That's great. Somewhere in there is probably something that would be useful, but what I want to show everyone is that I can just type in a straight out question in plain language and get the results I really want. So what would I say? I want to see what is the, how should I type this? What campaigns are my customers what campaign, here we go, what offers and campaigns are my customers responding to? See, just to prove it's live, I actually did all of that on purpose so that everyone can see we're actually live here with the software. So what I've got is not really what I'm after. What campaigns and offers? You know what I'm going to ask instead? I apologize. What is the rate of response to what is the rate of customer response to my campaigns and offers?
You're just showing off that the thing is analyzing that question as you type it.
I am kind of doing that. And also, there we go. So this is the one I want right here. And you can see it's got a number of others that are very relevant, somewhat relevant, but we're going to dive straight into this one here.
So the integrated natural language processing allows me to start thinking about the questions I want to ask in my data, not by looking at patterns in the columns already, but really by posing a question directly against the data that I've collected.
That's exactly right. And as you saw through my somewhat messing around there, it iteratively goes back and hits and hits. And what it's done now is another really cool thing, is it's come back with these results in a visualization that is appropriate for the results that I've got. Mm-hmm. So rather than me jamming sort of fields and then choosing a visualization I think looks good, it's giving me the most appropriate one. We've got some fairly simplistic answers here, so that's fair enough. But what I want to show you here too is this data trade. The curation of the data, the refinement continues.
Mm-hmm.
I can actually go in here and choose. I can filter. I can say, let's just look at married people. Let's look at some of the geospatial, suburban, urban, rural. You know, I can continue to do this iterative process with the data. So we can close that up. I can also do it. This I really like. I can do it through the interface. So instead of responses, I can look at education. I can look at employment status, right? And right on the fly, it's going to change. Let's go back to responses here. All right. So, as a marketer, what I'm interested in is people who actually do respond. It's not really much point looking at the people who don't, although, you know, arguably I could later on and sort of work out why not. But for now, and what we see is immediately apparent. Offer number 4 is a dud. Offer 3 is not so great either. Offer 2 is the winner. Offer 1's pretty good too. But let's drill into offer 2 here, right? So we're going to drill across, and we're going to look at this by state, because we're on the West Coast. And we can see, all right, California, Oregon, Arizona's not far behind, and it's keeping the visualization. So here's another cool thing. As you drill through and as you drill around, this intelligence behind the visualization keeps up with you. And it's made some recommendations based on my new view. And you can see here, I can switch to a map, which makes it readily apparent where I'm succeeding, right? There it is, California, Oregon. Here we are in Nevada, not doing much to lift our game, but we should maybe try and improve that one day. Let's switch back. So I want to go into some more things. I've got a lot of things to show you in a lot of time. We're going to add some rows. So here, I'm going to add a row about policies, because I'm interested in what are the policy types that these people have that are responding to us. And here's another cool thing. You see down here, we've got policy type and policy. One's auto insurance, one's homeowner. And what it's done is it's bundled them up into a roll-up variable automatically. So it's derived new information from my data.
Something that you would have needed a data modeler to do for you if you were sitting at the desk in most enterprises.
I gotta say, I would never have thought to do it as a marketer. I mean, it seems very obvious, you know, deriving information like if you told me your age, I could guess the year you were born, right?
Mm-hmm. Yes.
So what, 1970, something like that. Mm-hmm. So we pop this in, and what it's then going to do, people in that finally hit them, it's going to show us these different types of policy. So you see here, so we've gotten even better. Now we know it's people with personal auto policies. They're the ones that are responding. So I can drill in here, drill down and find out, okay, I've got the policy type. There are the policies. Policy number 3. So just like that, I've gone through data access and preparation, and I've managed to find out, when it comes to the campaigns, which ones are succeeding, which offers are succeeding, where they're succeeding, and the policyholders we're succeeding with. So that budget you're giving me, I'm going to turn the ROI like right up. I'm going to do a great job.
All right, well, let's get to work with it.
But there's more, and this is where it gets really cool. This kind of relates back to what they were talking about just before, you and the customer there at Pratt & Whitney. This is where we get predictive, and yes, I've jumped across, but if you go back to the welcome screen, you can see very quickly how I do it, predict and explain. And what we've got is the same customer set here, and inside this data set I have a customer lifetime value. And what this is essentially the revenue and the cost balanced out to then give us a value statement about them. So what I'm interested in is, okay, I'm going to really kick it out of the park here, right, with my marketing. I'm going to do this great campaign, I'm going to have this great offer, I'm going to get great results, but I'm going to hit customers, they're going to give us great revenue, great returns, all right? So I want to know, how do I identify these customers? They're going to have good lifetime value, because they're not at the end of it yet. So you can see we've got a predictive model here, and this is our marquee graphic. You've got the target, the outcome you want to know about in the center. And as you move away from the center along the spiral, those closest are the ones with the greatest predictive strength to that outcome. So right here I can see number of policies, 46.6. That seems fairly intuitive. I immediately would think, okay, the more policies we can sell someone, the more customer lifetime value you're going to get out of them.
But many times it's a combination of factors that give you the strongest result, right?
Absolutely. And you can see it. You're absolutely right. And what we've got here is it's already done that. It's made a suggestion, a more accurate and interesting insight. I won't read it out. Everyone can see it here. And that's the same thing as we go up. But I am more interested in getting super predictive. So down here at the bottom, I can turn it up. I want to get the most predictive model I can out of this. And that's all I had to do. And you can see exactly as you said, it's like you've seen this before. We've got the most accurate predictor is a combination of fields at 66.7%. That's pretty good.
So as a marketer, you just now use sophisticated predictive analytics against the problem you're trying to solve to understand what are those factors that are really going to affect customer lifetime value without having a statistical model or statement at your side.
That's exactly it. I wouldn't know a lick of data mining, and I've just done it all. I've done this predictive analytics very well. And it gets better, because now I can drill. You can see this decision tree. And these are quite cool, because it gives you a sort of a breakdown of like, okay, what is it that you have to look at to sort of filter out a good customer? And this one's actually a bit complex. I mean, I can zoom in, and I can sort of look at the first breakpoint and see, there we are, number of policies. So obviously there are lots of policies that are going to be, very useful to us. And, it gets a bit more complex as I drill down the tree. So what I can do instead, this is, getting beyond the black box of it all. I can see what's going on. I can get rules, straightforward language, and I can say, look, number of policies, and here's something interesting. See, number of policies equals 2 is consistent across the board. So it's not a customer with the most policies possible, it's a customer with 2. And I can see my top group, highest maintenance, so they're paying premiums, they've probably got expensive cars or teenagers. They've got a collective policy, so they're on a family plan, and that's the top. So when I get my $1 million of marketing budget out of you for this, I know the offer I'm going to use, I know the state I'm going to go after, I know the policyholders, and I now know who are the people I want to get first on the list. If I have money left over, great, I'll go to the second rule. If I have any more left over, the third rule. But I am going to get the highest valued customers for us through that campaign. And then, we can also look at, I think this is a good way to do it too. You can see what are the strongest predictors in a word cloud. And one thing that's occurred to me in doing this analysis, which is quite cool as well, is that yes, I should do this campaign to get these people to renew, and now I have a very targeted way to do it, but I've thought of a new one. Let's go after people with 1 policy and simply get them onto 2, because then we've got them on the path to being a great customer.
Another great insight. Marcus, thank you very much. Fantastic work. Thank you.
So we could break now, and before we get into the next session, which will be covering RightShift, presenting risk management process they have in place. Investigate more about that RightShift. So I'm not sure how long is this break.
So the beer's drunk, eventually.